So this is 6.3, number 37. We're doing a volume of revolution around the y-axis. So we have three functions. We have the x cubed, y equals 0, and x equals 2. And so I've shaded in the region that's being rotated around the y-axis, which is the equation x equals 0. Now you need to know the point at which they intersect. So how do you find that point? Well, I know x is 2. How do I know that? Because this gold line is 2. How do I find the y value? That's pretty easy. This blue line is y equals x cubed. So if I want to know the y coordinate of the blue line, I just plug in 2 here and I get 8. So I know that's 2, 8. And so the first thing we're going to rotate are the gold line. This is going to rotate around this axis. If I do that, let me make some nice, beautiful circles. Not this again. Uh-oh. It's not going to happen. There we go. That's actually not exactly what I wanted, but it'll work. I'll fill it with the, yeah. It's not very flat. It's diagonalized a little bit. And it's way too wide. Okay. Yeah, it should be flat, but it's not. Hopefully the next one will be flat and I can redo these. So you're gonna have these up and down. Ain't gonna happen. Try it again. Ooh, that's a good one right there. I like that one. That's a goody gumdrops. In fact, I'm gonna duplicate this over and over and over because I like that one. I'm gonna get rid of this one. Woo! Oops. Bam. And you'll see they're all the same all the way up and down. Because that gold line's the same. Actually, these should be a little fatter. I messed up a bit here. I'll do 2 more of these, one here. And the last one's at the very bottom. So you will produce a big cylinder. But if you find the volume of that, we have a problem. And I will show you, but we're going to find the volume of that. You add up all those disks. I add them up by integrating, and I start at 0 and end at 8. You should know why. The first disk is y equals 0. The last disk is y equals 8. So I need to add all those up. And it's pi, and I'll call r1 squared dy. Why? Because the thickness of a disk, as you move up and down, it's a change in y. That will be dy. Okay? So I'm going to point something out in a second here that you could actually do on an AP test. You don't have to use calculus to find this volume. If you understand, this is just a cylinder. And if you want the volume of the cylinder alone, all it is pi r squared h. The radius of this is 2. So you could do 2 squared, and the height is 8. So that's just 32 pi. So you could actually put this instead of that. You don't have to integrate. If it's a shape that you have geometry, you can do geometry. Okay? But I'm just going to put that there so you get an idea of what's happening. But hopefully you see that this is like a vase. When I rotate, this is the part that's going to be solid because this is solid. So as I rotate it, and it's going to have an empty middle part. So if you want the volume of the actual materials to make this shape, you don't want the middle because that's not part of the shape. So we need to subtract the volume of the inside part. And that's what I'm going to do next. So I need to subtract pi. We're still going to go from 0 to 8, but we're going to have a different radius. And actually, I didn't even find R1 for you yet. What is R1? So R1, this is the general form of all volumes of revolution when you have a hollow center. And the secret to find R1, it always goes from the axes to the farthest graph away. So you have two, here's your axis right here. You have two graphs, the blue one and the gold one. Which one's farther? Whichever one's farther is going to be your first R, because you want the volume of the big part, subtract the volume of the small part. So that R will go from the axis of rotation to your function there. That's R1. And that's going to be big X minus small x. But what is big X? The further right you are, it's bigger, and to the left, it's smaller. Do we know X at this point? Well, it's X equals 2. So that's going to be 2. And small x is the y-axis, but on the y-axis, X is always 0. So that's going to be 0. So for the first one, we will get this. R1 is 2 squared dy. Now we have to figure out the other r. And so I'm going to do some manipulation here. I'm going to change these things to match the inside. So this one, I'm going to go to the closer one, the blue one there. Same thing with this one. I'm going to go to the closer one, which is the blue one. And this one to the closer one, which is the blue one. And this last one is essentially 0 because it's like right. Yeah, can't even see that. I guess you can see that. Okay, so you will add up all of these, okay? Now let me show you kind of what's going on the other side. That's kind of what you're seeing on the other side. So it should be obvious that all these discs I have here are the hollow part in the middle where there's nothing. So we want to take away that. So we need to find R2. Now R2, here's a little shortcut. R2 always goes from the axis of rotation to the closest graph. It's a shorter one, and the blue one's closer. So your R2 is going to be right there. So R2 is still big X minus small x, but the big X is the blue graph. Now, you want big X. This is Y. Y is X cubed. That's no bueno. You want X because it's big X. So what you're going to have to do is take this equation here and solve for X. So you're going to have to cube root both sides. And you'll get X equals the cube root of Y. That's going to be your big X, because the blue line, X is cube root of Y. And your small x is the y-axis, which is X equals 0. So you have a minus 0. And we will plug that in. And now the rest is just taking antiderivatives. So let me do this. The antiderivative of 4 is just going to be 4y. For the second one, I'm going to rewrite it because y, cube root of y squared is this. Remember, the bottom is the root, the top is the power. This one, I'm going to go ahead and plug in 8. Then you plug in 0, and it's just 0, you can see. Minus the antiderivative of this, you add 1 to the exponent, which is 5/3, but then you divide by 5/3. Let's keep going. And at this point, I want to note, after we took the antiderivative, we got 32 pi. If you would have used pi r squared h, you also would have got 32 pi. So you could have done that and saved yourself some time. Now, dividing by 5/3 is the same as multiplying by 3/5. So I'm going to put a 3 and 5 here and get rid of that. And so I have minus, plug in 8. 3 times 8 to the 5/3 power over 5 minus, then you plug in 0, but clearly if you plug in 0, it's 0. We're almost done. So this is saying the cube root of 8. So to make it more obvious to you, I'm going to write it like this. My first question, what's the cube root of 8? You should all say 2. And then 2 to the 5th, 32. And then 32 times 3, 96 over 5. I have a feeling I missed something. I did. I had a feeling it wasn't right. I forgot my pi. What a sin to forget your pi. That's like my favorite. I'm going to move the pi all over here. Okay. They got a common denominator. They said, you know what? We need a common denominator of 5. So I'm going to multiply by 5 over 5. And that's going to give me 160 pi over 5 minus 96 pi over 5. And 160 minus 96, that's 36 away, 64 pi over 5. Is that right? It's not ringing a bell, but hopefully that's right. Yes, I like it when it works out like that. All right, that's